Okay, this is a question on application of differentiation. Okay, firstly, a trapezium ABCD has a pair of parallel fixed sides of length ACM and 2ACM. So the other two sides of the trapezium are increasing at the constant rates of 2cm per second. So this side is ACM and this side is 2ACM. The other side refers to this side and this side. Don't mistake it for the vertical height. Okay, this is not the other two sides is not the vertical height because they are not the sides of the trapezium. The vertical height is not the sides of the trapezium. So given that angle ABM and angle DCN equals to theta, so theta stands for the same value, how fast is the area of the trapezium changing when theta equals to 60 degrees? To do this kind of question, we start from the question first. We don't care about this block of information first. This entire block of information, we don't care about it first. Alright, actually the entire block of information stretches from here to here, okay? So we don't care about it first. What we care about is what they ask of us, which is this part. What is the question asking? It's important to identify that first. So let A be the area of the trapezium. We write down the question in mathematical format. So what does it means? So the area of the trapezium changing. How fast is the area? Fast. How fast means the rate of change of area. Because we are talking about time over here. And the area is the thing that is changing. So the thing that is changing will be on top. And the thing that is varying will be on or at the bottom. It's always the case. Let's say the rate of change of volume would be this. If I talk about rate of change of volume with respect to the surface area, then it would be this. With respect to what would be below, right? Because we are varying the area. In this case, we'll be varying the area. Okay, so that's case. Now, dA over dt. When we always indicate with a vertical line, theta equals to 60 degrees. So therefore, the first thing we can think of is the chain rule, okay? How to get from here to here. Then before that, okay, this is what we want to find out. And what is it that we have? Now we come to what is it that we have? What are the clues that we have? They say the other two sides of the trapezium are each increasing at a constant rate of 2 cm per second. Okay, we let this side be, what is this side? Okay, we could let it be y, okay, and see then what is the rate of change of y. The rate of change of y according to this sentence would be constant rate of 2 cm per second. The two sides are changing at the constant rate of 2 cm per second. So dy dt equals to 2. Okay, actually I know that this is also y. How do I know it? Because this is also h. Okay, if theta is the same, if the theta and theta here is the same, and the h and y is the same, so tangent theta, sine theta equals to h over y. If I know that this h is and his h is the same, then the y must be the same because they have to follow the same ratio. Okay, which means that this side will also be the same as this side. Okay, because the cosine theta will equals to this side over this side. Right, since this and this side and this side is the same, then this side and this side must be the same. Okay, because we can also think of it as the rule that the congruency, right, and similarity. Okay, we have a right angle triangle, and there's the same angle. That means this angle must also be the same. If this is a right angle triangle and this is right angle triangle, these two angles are the same. This means that this angle must also be the same as this angle because sum of angles might add up to 180 degrees for both triangles. So this angle must also be the same as this angle. Since they have all three angles the same, That means they are similar. We have established that they are similar triangles if all three angles are the same. Plus they have one side the same. That means they must be congruent triangles. Okay? So since these two triangles are congruent, so the three sides must be exactly equal. So since this side is equals to the length of this side, then what must be its length? So you compare this length with this length. These two lengths are parallel. So 2a minus a. So that means since two lengths are parallel, this length is a, this length must be a. So then these two lengths add up must be a as well, because when these two lengths add up, a plus a will give you 2a. Okay, so these two sides add up to a, so each single side is half a. Can you see that? Okay, so each single side is half a. Then we look at this. So cosine theta. So now let's say if we express everything in terms of h and a, then this length is, by the Pythagoras theorem, is square root h square plus half a square, isn't it? Square root the square of this plus the square of this, because this is the longer side. Okay, so but before that, okay, why do we need to find all this? Okay, the reason is this. Okay, you have dy dt. Okay, so what is dA dt? dA dt, we know what is area of trapezium. Area of trapezium is defined by half times height, which is h in this case, and the sum of parallel side a plus 2a. Okay, equals to half times, okay, it's easy, 3a plus 2a is 3a, so 3 over 2 ah is the area of the trapezium. So then if we have this, and we know that we want dA dt, intuition is like we have to find dA dh. dA dh, because h can be differentiated. A can be differentiated with respect to h. So we want to find dA dh. We want dA dh, how do we get to here? So dA is here, so dA must be on top, and then we want dt below. Therefore, and the medium, the connecting one is dh, so that this would cancel away with this, and then we'll get back to dA dt. So dH dt, okay, dA dH, can we find dA dH? dA dH we can find from here. So dA dH is just 3 over 2a. Okay, simple, because a is a constant, so we can just differentiate the h. Okay, then that means we have 3 over 2a times dH dt. What is dH dt? We don't know dH dt, but we know dy dt. Okay, so the intuition is dH. We want dH on top, and we want dt below. We have dy dt, so we let this be dy dt, and then this would be dy as well. Okay, so when these two cancel, you give me back to this one, right? So then what is, so this is 3 over 2a multiplied to dy dt, which we know is to be 2, multiplied to dH dy. So we are left to find, what we are left to find is just dH dy. So we must find a equation that connect h and y, isn't it? So let's see what we can do.